Hey everybody, and welcome to the Chem 115 supplemental video series. So, a quick introduction. My name is Lauren, and I absolutely love teaching people chemistry. Because whenever I first started taking my college chemistry classes, I felt like I didn't have a clue as to what was going on. So if you're feeling like that, for whatever reason, just know you aren't alone. Chemistry is a really challenging subject, but when understood, it can be super rewarding and a really fun and positive experience. Cool. Now with that sappy stuff out of the way, let's get to the first topic in this series. So the first topic is going to be on what is called dimensional analysis. Now, if you were like me whenever you were sitting in that chemistry lecture, you were like, yes, okay, significant figures, temperature, a lot to remember, but we'll get there. Oh, dimensional analysis? What? And you look over at the person next to you and you're like, what? What is this? So why do I need this is what you've probably been asking yourself. Well, here's an example to contextualize. Let's say you're doing a study about weight in a population in the United States. If you grew up in the United States like me, you probably measure your weight in pounds. However, the rest of the scientific community, and a lot of the world in general, communicates weight in kilograms because, as you may recall, that's part of the metric system. So, as scientists, we want to be able to communicate our results to the rest of the scientific community. So we must convert from pounds, which is an American measurement, to kilograms, which is what we need to communicate with the rest of the scientific community. Now, this conversion of units is dimensional analysis. Now, I just want you to take note that all that's happening is you're expressing the same property, which in this case is mass, in different units. You aren't changing the measurement, just the units that express the measurement. It's just a different form of communication in different units. Just wanted to point that out and make sure that we understand that before continuing. So now you're like, Lauren, I understand what dimensional analysis is now, but how do I do it? Well, in order to convert between your units, you use something called a conversion factor. How I explain conversion factors to my students is effectively how you get there. So if dimensional analysis is the actual conversion from pounds to kilograms, the conversion factor is mathematically how we perform the dimensional analysis. A lot of you have actually probably been exposed to conversion factors and just hadn't known what they were called yet. Chances are some of you have gone to Google, maybe for a math problem, and you said, Google, I need pounds to kilograms. I need kilograms to be able to solve this problem. And Google can do that conversion for you. What it uses and what I'm showing you on the screen right now is the actual conversion factor. This is the conversion factor that we use to mathematically solve for kilograms from units of pounds. What is cool is you don't have to memorize conversion factors unless they're part of the metric system like you've already learned about. You just need to know how to use this conversion factor. So you're asking now by this point, how do you use a conversion factor? Well, you first have to set up your current units. Say we have someone who weighs 150 pounds and we want to convert their weight into kilograms. We set it up like this, 150 pounds over 1, so that we have units in the top, the numerator, and no units in the denominator. You don't have to specify this here in the denominator, but it just helps me to conceptualize things, and it may help you too. So what we're trying to do is we're trying to cancel our units of pounds out completely, Because as you know, if we have the same units in the denominator as the numerator, say if we had 1 pound over 1 pound, the units here in the numerator and the denominator effectively cancel each other out. So if we use our conversion factor here, then we can cancel out our units in pounds by multiplying our original value by our conversion factor in such a way that gives our units of kilograms on top and leaves our units of pounds canceled. As you can see here, I've set up my conversion factor to where when we multiply these two things together, this thing and this thing, we're going to cancel out the units because we'll have pounds in the numerator and in the denominator. And then we'll have kilograms left by itself in the numerator. So you need a little bit of a closer look at that. Here I am showing correct mathematical notation where I have my multiplied product all in the same fraction. So here we can clearly see there's pounds in the top, the numerator, here's pounds in the denominator, they must cancel, and now the only things left that I can't cancel because there's nothing to cancel them with are my actual numerical values, which is the measurement and the conversion factor, and my units of kilograms. So then plugging it into a calculator, we get an answer of 68.0 by sig figs kilograms. Here are some examples of how your teacher might have been writing it, just so you can compare with your notes and see that ultimately it's the same thing, just written out a little bit differently. Great. So now I'm going to give you an example like this one, and I want you to pause and try to convert the units as specified in the problem. Once you think you're done, and pause, and we will work through it together. So here's the problem. Given a second to pause. Sweet. So now we're going to solve together. So what I've done here is I've set up my problem in the same way I would start to by first listing the units that I'm going to convert out of, which is right here. I know this because the problem says the mass of a competition frisbee is 125 grams. So I know that I'm going to want to convert from grams into what it asks for, which is ounces. So I looked at the conversion factor, and lucky me, it provided it for me. So that conversion factor, I've written the way that I will multiply it, which is the conversion factor 1 ounce for every 28.349 grams. So then what I do is I start to multiply my value, which is right here, the original value, by my conversion factor. And again, why I have written it this way and maybe not flipped or something like that is because I want to have grams in the numerator and the denominator to be able to cancel them. And as you see, if I multiply this out, my product will have grams in the numerator, grams in the denominator, and the thing that I want, the unit that I want, ounces, will be in the numerator by itself. So then I do the math with my calculator. And because we detail the answer in 3 significant figures, because our conversion factors do not have any weight on significant figures, we report our answer as the mass of the competition frisbee in ounces is 4.41 ounces. And that's our answer. Great job, guys. So now I just want to walk you through how to solve a word problem, because reading them can be a little bit challenging, and we're going to have to do dimensional analysis problems that are a little bit more complex than the one we have in front of us. So here's a problem regarding dimensional analysis that you might have on an exam. The way that I like to read these problems is I first want to know what they're asking of me for the final answer. So what are they asking you? That's right. It would be the density of antifreeze in grams per milliliter, which is in the first part of the problem. So very, very blunt, really like that. From class, we learned that density is equivalent to mass divided by volume. And the units that the problem wants corresponds with this. Grams, which is a unit of mass, and milliliters, which is a unit of volume. Now, I identify what I am given otherwise, and how that will give me the units that I do want, which, again, is my grams over milliliters. So there is a 4-quart sample. What property does that unit quart correspond with? Well, that is a measurement of volume. Likewise, the pounds in the 9.26 pounds are units of the property mass. So we can convert pounds to grams because they represent the same property. And likewise, we can convert quarts to milliliters to give us the units that we want to determine our density. So now we have to use dimensional analysis to solve for density. And we can do that in 2 ways, both of which are dimensional analysis, just different ways of thinking about it. And I'm going to show you both ways of thinking about it as well. The first way is to convert both of these units separately, almost like I've listed here, and then divide them to get density, which may be more helpful starting out when we're a little bit less comfortable with dimensional analysis. So the first things that I do is I'm starting from mass, and I write out what my pathway is going to be. So because I know the unit conversion factor from pounds to kilograms, that's my first one. Then my second one is my metric conversion, which you should know from kilograms to grams. So now I set up my problem, and what we're doing here is we're going to actually have to convert twice, right, as we listed in our pathway. And both times, all we're doing is we're canceling out the units that we don't want to get the units that we do using the conversion factors. In the first one, we're converting from pounds to kilograms. So you could even do this separately, right? You do it as step 1 and step 2. But I've chosen to list it as one thing because I think that's actually a little bit less confusing. So I write out all my conversion factors and I make sure that everything cancels the way I want it to. So I don't want pounds. I need to convert to kilograms first, as I showed up at the top. So I make sure that my pounds cancel. They do, and that gives me kilograms. But I don't want kilograms, I want grams. So I make sure to write out the proper unit conversion from kilograms to grams. See that my kilograms cancels in the numerator, the denominator, so my answer will be given in grams. So now I write out my answer in the correct significant figures. So when I plug this into my calculator, I got 4,203.2992 grams. I'll write grams there. But because we have to, I made a mistake there, use 3 significant figures because our original measurement contains 3 significant figures, we have to write this in scientific notation, which is what I have done here at the bottom. So that's our answer. Now we have to move on to our dimensional analysis for our volume. So as with mass, I've written out my pathway, which is from quarts to liters to milliliters, because I know a conversion factor from quarts to liters, and then liters to milliliters, we use the metric conversion factor as we did with grams. And I write out my conversion factors. So here are my conversion factors. So now I'm going to write out the problem, how I would solve it. So here I've written it out again in a way that we will cancel the units that we don't want and get the units that we do. And I check to make sure that it cancels. Quarts are in the numerator, quarts in the denominator, liters in the numerator, denominator. We're left with only units of milliliters. And here are my answers written out. One which is not in the correct significant figures, but it's what the calculator spits out. And then here it is in correct scientific notation, which we use because we need to express it, again, with 3 significant figures. So now, to solve for density, I put my grams and my milliliters, for which I have solved for already, into the equation, and I divide my grams by my milliliters, which is written out, and then I get the answer 1.11 grams per milliliter. and that is correct in terms of significant figures. It is the correct density. That is the answer. Another way that you can do it, which is easier and quicker once you get the hang of it, is to divide the units you have to give density, which is still mass, divided by volume, just in like the original units that we have, which were pounds and quarts, and then convert all of them in one fell swoop. This uses what I call a conversion box. We set it up before the conversion to make sure that we don't mess up cancellations. So all that I've done is I've set up my pounds to be converted into grams in my conversion box first, using the same conversion factors. So my pounds cancel, my kilograms cancel, my kilograms cancel, leaving grams. There will still be grams at the end. And then you can see that I have canceled out my quarts. My quarts are here, they're here. My liters cancel, left with milliliters in the denominator. So then that ultimately gives grams over milliliters in one fell swoop with the same exact calculations, same significant figures, and we get the same answer, equals to 1.11 grams per milliliter for my density. And that is how you do it. Dimensional analysis, that is. Well, thank you for sticking through it with me. This stuff can be tricky for starting out, and I wanted to give ample time to explain dimensional analysis because it's used in literally every other chemistry class that you will ever take. But you've got this. Make sure for more practice to see the worksheet that I've attached for you all. And I want you to try and complete the worksheet before looking at the answer key, just because it'll be better practice that way. If you guys have any questions, let me know. Bye now.